Welcome back everyone to Data Science for Everyone. Today we're going to be looking at the MovieLens 1M dataset. Let's get started. So first off, this data is a collection of movie ratings data collected from users of the MovieLens from the late 1990s all the way up to the early 2000s. Now the data provided gives us some movie ratings, some movie metadata, so for example their genres and year, as well as some demographic data about the user, so age, zip code, gender, some sort of gender identification, their occupations. Now this data is often of interest in the development of recommender systems, okay, for machine learning. I think we've done some of this in the past, but we haven't really done any just kind of playing with the data itself, which we can do. So while we don't necessarily explore the machine learning techniques today, okay, we have done that in the past. I'm going to show you kind of how to slice and dice this type of data set to get exactly what you want. Now, the MovieLens database contains almost 1 million, so that's what for the 1M is 1 million ratings collected over 6,000 users on 4,000 movies, okay? And it's spread across usually 3 different tables of ratings, user info, movie information, and a lot of the time, so after extracting this data from some sort of zip file, we're probably going to have to read it in a little bit different way. So let's go on and maybe look at what data we have. So we have, let me say, ls data movie lens, and maybe I saved it as that. Okay, so I have in here 3 different CSV files, and I'm going to go on and maybe before we even look at too much of this, I'm going to look and do the head of this with bash. So movies.csv. Let's double check that they are, notice here, there's something here. These are not actually comma separated values. Yes, it says it's a CSV, but that's not, that is a semicolon, okay? So let's also go on and do this then for the ratings. Ratings, again, it is a semicolon. And let's also go through and double check in here our users. Users is also a semicolon. So whenever we read this in, we can use the read_CSV, but we also need to make sure that we are grabbing in with a with the correct delimiter, okay, which is a semicolon. So let's go on and import pandas as PD. And let's go on and do something like unames. And you know what? Let's see actually what it actually has in here for like our user ID, gender, age, occupation, zip code. I actually kind of like the way that looks. So let's go on and do something like users equal to pd.read CSV, and then we have that. I'm going to go on and grab it here. And you know what? Let's actually do this a little bit differently. And let's do path plus. And I'll do path is equal to this. So then we can actually just add it in each. And we have a separator in here is a semicolon. And then we'll do this for each of the others as well. So ratings is equal to this, and ratings. And we also have in here movies is equal to this, and we'll change this to ratings, and we'll change this to movies, correct? Movies, ratings, users, ratings, movies. Okay, we'll run this. Whoop. And what did it not like for our decoding? UTF-8 codec. So one of the things that sometimes when you have these non-standard type CSV files, okay? So for example, I have this separator here. It's most likely or not, sometimes you'll have it that it's in a different language. They use maybe a different keyboard. So then you need to go about fixing this UTF-8-code codec, okay, issue, because again, it's going to have maybe some special things here. Maybe this is a SETA or something else, okay? So there are a couple different ways that we can actually deal with this. So let's go on and bring it up here, and we'll kind of go through each of them kind of in turn. I'm going to go on and comment out 2 of these so that we can kind of play with it. So notice here that this users one didn't have any issues. So let's go on and maybe undo, and let's double check to see if it's the rating. Okay, the ratings actually ran through. So then if we go back through and we double check this, notice it is the movies data set that is having the trouble. So all we have to do is find the correct encoding for this. Now, a couple ways we can do this is just do encoding here, and we can try the UTF-8. Okay, that's kind of the standard. We run this, and again, it's going to have the error because, again, it told us before that this UTF-8 codec can't decode a specific type. Now, from just some playing that I've done in the past, okay, we can also try maybe do something like Latin and run this, and usually that has a tendency to work, okay? You may also try different ISO encoders, but I would suggest maybe you guys just kind of Google around to see if these two UTF-8 doesn't work, or changing it to encoding Latin doesn't work. Maybe, for example, you have some Chinese data, or you have Thai data or something else, or Japanese data. You may need to get in different encodings for those as well. So this happens to work. So let's go on and maybe take a quick look at our data. So I'll say, let's see, for data frame in users, ratings, movies, we're going to print df.head, and then we'll also print just some nice line here. Okay, I'll take a look. So user ID, gender, age, occupation, zip, user ID, movie ID, rating, timestamp, movie ID as well. So these are things that we're going to be using. And notice here we also have this unnamed. So again, we have some basically some trash data in here as well, but that's okay. So these are all the things that we're going to look at, and we may want to go on and merge these data into something useful for us. And so let's go on and do that. So we can say data is equal to pd.merge, and I'm going to do this nested wise because we have 3 data sets. So pd.merge again, and we'll do our ratings and our users. Okay, because if we look here, our users has a user ID, our ratings has a user ID as well as a movie ID. So we want to merge these two on our user ID, and a merge pd.merge is going to check those for us. And then we also want to do the same thing, so both of these two merge together. The one that they'll have in common is this movie ID. Okay, so then the next one here is comma movies. Okay, and then now we have data.head. Look here, and we have all of the data. I'm relatively annoyed by this unnamed data, so we're going to drop unnamed, I believe it'll be 3, axis 1, no, let's try axis 0, no, key, axis 1. Okay, so there was a space in there, so and let's do in place true, and now we can actually look at data.head again, and we have our nice clean data. We may we could also change this to just zip or something else if we wanted to, but I think it's okay the way that it is. So this is great and all, but let's actually look at a single movie at a time. Okay, so what we can do is something like data.iloc at 0. So we'll grab that first one. And this is One Flew Over the Cuckoo's Nest. It's a drama. The zip code. We have occupation of 10. I don't know what that is, but we can maybe find it out. Timestamp, gender, age, all of this type of information. Now, we can also grab and maybe do some other type of thing. So maybe let's get the mean movie average for each film grouped by maybe gender. Okay, and we can do this with a pivot table. So you guys maybe remember the video that we did on pivot tables. So let's do something like mean ratings is equal to data.pivot table, And again, we want the mean rating. And we want the columns is equal to gender. And our aggregate function here is going to be mean. So here we can see $1 Million Duck is going to be 1, and here notice we have our mean rating. So again, these are like usually 5-star reviews, that type of thing. So it's a 3.75. We actually have some that have none in here. So maybe we would want to do fill in A of just saying none or nothing instead of just having this nan values. Now, this produced another data frame that's going to be containing, again, our mean ratings of the movie titles as a row. Okay, that's the row here. And then we have the gender columns for our male and female as well. And I also want to maybe first filter down movies with at least 250 ratings. Okay, and then again, that's just a completely arbitrary number for us. And then we maybe want to group by size and title. So let's go and do a little bit deeper dive on this, okay? So how are we going to get this, how many movies received ratings? Well, how do we do that? Is the size method. So ratings by title. So it's data.group by title, and we want this by size. And then we can let's look at just the head of it. And so here you can see that some of them have it, some of them don't. So let's just say we want them, let's call them active titles. Ratings by title greater than or equal to 250. By title. Okay, so then we can do active titles dot head. Yeah. So then here we can actually, and you know what? Maybe we do print. List. Nope. I want to make it a little bit prettier. So let's do something like for title in active titles dot head of 20 print title. Let's do it a little bit differently. There we go. So now we have the Burbs. We have 10 Things I Hate About You, 101 Dalmatians. So again, we have kind of this nice list of those that have over 255. But maybe now we want to actually grab out those mean ratings. Okay, and we'll do those by male and female. So now we have our new mean ratings is equal to our mean ratings.loc. And again, this is the index location of our active titles. Mean ratings, okay. Mean ratings. So now we actually have that as well. And these are the ones that have at least 255 ratings. Now let's also see maybe the top films for female viewers. So we can sort by this F column. And so we'll do something like top female ratings is equal to mean ratings.sort values by F. Ascending is false. And so top female ratings dot head of 10. So Close Shave, Wrong Trousers, Sunset Boulevard, Wallace and Gromit, Schindler's List, Shawshank Redemption, Grand Day Out, To Kill a Mockingbird, Creature Comforts, The Usual Suspects. Okay, so maybe we can also measure something like user disagreement, okay, which can be quite fun. So for example, what's the movies that have the most difference between the male and female users? So maybe we'll do this again by the mean ratings. So mean ratings diff is going to be our mean ratings of male minus our mean ratings of female. And then we can do something like sorted by diff is equal to our mean ratings dot sort values by equal to diff. And let's do sorted by diff dot head of 10. Head of 10. Okay, so Dirty Dancing, Jumping Jack Flash, Grease, Little Women, Steel Magnolias, Anastasia, Rocky Horror Picture Show, The Color Purple, Age of Innocence, Free Willy. So these are the ones that have some of the most difference, but then let's also look at the reverse ordering of this top 10 here. Okay, so this is the most negative difference. Let's look at the most positive difference. So what we can do is this sorted by diff, and then we're going to reverse the whole thing, dot head of 10. So then this, The Good, Bad, the Ugly, Kentucky Fried Movie, Dumb and Dumber, Longest Day, Cable Guy, Evil Dead, Hidden, Rocky 3, Caddyshack, a few dollars more. Okay, so we get the movies. These are the movies here that, these are the men preferred films, okay? And then these others here are the women preferred films. Okay, so this is kind of nice to be able to look at the differences between these two. Now, suppose we wanted to give the movies that elicit the most disagreement among viewers independent of their gender. Okay, so the disagreement measure can by the variance or the standard deviation of the ratings themselves. Okay, so we don't care about the gender of the individuals. We just want to see what the deviation is of the actual ratings by the title. Okay, so the way we would do that is go about this with our rating standard deviation by title is data.group by here the title. We want the rating and we want the standard deviation of that rating. Then we'll do rating standard deviation of by title here is going to be equal, and again here we want to filter down to the active titles. Okay, so we've already found the active titles before, so we want the rating, the standard deviation by title of our active titles. So then we can do rating standard by title dot sort values. Ascending is false, and we want the top 10. So the most kind of divisive as there are apparently seem to be a foreign student, criminal lovers, talk of angels, and let's double check that we have. Oops, I don't want this. I actually want .loc. That's why things are looking a little weird for me. And we'll run this again. There we go. Okay, so again, there's going to be some difference. Now we can also separate out things with the pipe operator, and we can do a lot of other types of things like looking by the genre or a lot of different other transformations that we can do. But again, this is all up to how you want to work on this data and what type of story you're wanting to tell. So if you guys like this, please comment, subscribe, and hit that like button, and I will see you guys next time. Bye-bye.